Okay, in this section we're going to find composition of function. So here, if you have two functions, then you are going to combine them in a very specific way. That's called composition of function. So sometime they give you uh, you know combined form of the functions, and then we are supposed to decompose that into two different functions. So these are the goals. So first of all, let's define the composition. This is the notation you have to be aware whenever there is a composition. So this is the notation we use. This circle looking symbol that represents the composition. So if you are trying to find the composition of f and g, then that is the finding the value of f at g of x. Here g of x is the inner function, so whatever comes to the right, that goes inside, and whatever comes on the left, that goes outside. Keep in mind the meaning of f composite g and g composite f could have different value, so you always have to use this formula for finding the composition. So another thing in this section we're going to discuss is how to find the domain of the composition. Okay, and I'm going to talk about that later, but first of all, let's find some composition. Let's go to your homework problem. Let's say you have a function f of x and g of x, and you want to find the composition of z and f at 9. So let's find out the function uh, composition. In this case, let's say the function g of x, it's g of x is given, which is x square minus 3x minus 4, and f of x is also given, which is 2x plus 3. We would like to find out the composition at 9. So before that, what we can do is we can find the value of, look at here, z composite of f at 9. The meaning of this is find the value of z at f9. So meaning you need to find this value first. What is the value of the function f at 9? For that we have to use this formula. So 2 times 9 plus 3 is 18 plus 3, which is 21. So we want to find out the value of z at 21. That's the composition. Okay, so for finding that value, we go here and replace x by 21. So the value of z at 21 is 21 square minus 3 times 21 minus 4, which is we can use a simple calculator here. 21 square means what is 21 square? It's a 441. 441 minus 63 minus 4. So 441 minus 63 minus 4, that's the value, 374. So this value is 374. Okay, that's the composition. And by using the same way, we can find the composition of two functions. Here in this case, we need to find the composition first and find the domain of each of them. So for finding the domain, I'm going to show you the rule, but before that, let's find out the composition. So what is the composition of f and g? Here, keep in mind the function f of x is 6x minus 4, and function g of x is x plus 4 over 6. So f composite g of x, this is finding the value of f at g of x, meaning go here and replace x by the value of g of x. So I go here, I replace x by, wherever I see x, I replace x by this value. In this case, it's x plus 4 divided by 6, and I can just cancel this, and it will be x plus 4 minus 4, which is x. So that's f composite g. And what about the z composite f? So according to the formula, find the value of z at f of x, meaning this time go to the g of x and replace x by the value of the function f of x. So here, instead of x, replace that by 6x minus 4. And then the leftover plus 4 divided by 6 would be there. Plus and minus 4 gone, 6x over 6. So that is also x. So now we know the f composite of x is x itself, and g composite of f is again x itself. Now the big question is how to find the domain. So for finding the domain of the composition function, you have to use this rule. For finding the domain, first of all, find the domain of inner function. And then after that, find the domain of the final formula which we calculate using this. And then finally, this is supposed to be number 3. Number 3 is supposed to be find the intersection between these two. So let's go back and look at, let's try to find the domain of this one. For this one, first of all, find the domain of g of x. In this case, the domain of g of x is, there is no restriction, so it's all real number. And find the domain of this final formula. Final formula means this one. The domain of this one is all real number as well. Now, the domain of the composition would be the domain of g of x and the domain of the final formula. In this case, it's all real number. So the answer is supposed to be all real number, which is from negative infinity to positive infinity. So same thing we're going to apply for this g composite f. First of all, find the domain of f of x. In this case, there is no restriction, so domain is all real number. And then second, find the domain of this final formula, which is again all real number. That's the reason the domain of this is also all real number. So that is also all real number. Okay. Let's do one more for the domain of composition. Where is that? I just want to do the one part. Okay, look at here. I'm not going to find the, okay, let's do it. Let's do this. Okay. Okay, let's do this. We have this function f of x, which is square root of x plus 6. Because it's a radical sign, the domain is anything where x plus 6 is greater or equal to 0. If you solve that, x is greater or equal to negative 6. So domain would be from negative 6 to infinity for f of x. For g of x, the domain would be all real number because there is no restriction. So it's from negative infinity to positive infinity. You always have to know this information. Now, find the f composite g of x. So this means go to the function f of x and replace this x by the value of g of x. So in this case, this x is replaced by x square minus 6. So this is gone. Square root of x square is x. Okay, it's actually absolute value of x, right? It's not negative, it's absolute value of x. Okay, can I write it? Yes. The reason it's absolute value of x is, square root of x square. This x could be positive or negative, but inside the square root it has to be positive. That's why it's absolute value of x. Now g composite f, you can do the very same thing here, and so g composite of f. So let's go back here and find out the function g of x is x square minus 6. So z composite of f, x means find the value of z at f of x, meaning go to the function g of x and replace x by this value, which is square root of x plus 6 whole square minus 6. That's x plus 6 minus 6. So that's x. So the answer for this one is x. Now, what is the domain of f composite g? By using the very same formula we learned, find the domain of inner function, find the domain of final formula, and find the intersection between them. Here, if you try to find the domain of this one, the inner function is g of x, where the domain is all real number, and final product is absolute value of x, which is also the domain is all real number. So the domain of this f composite g would be intersection of that, which is again all real number. What about g composite of f? In this case, inner function is f of x, so the domain of f of x is this one, and then final formula is all real number. So when you try to take the intersection between these two, the intersection would be the smaller one, which is this one. So the domain would be starting from -6 to positive infinity. Okay, that's all. What else? Okay, sometime they might give you the function and you can also decompose that. That's called the decomposition, but I don't have any problem like that in this homework. So that's all for this section.